Okay, let's say for example we are doing we are storing enthalpy change reactions using Hess law. So this is the reactions. Let's say I have combustions of ethane, right? C2H6 plus oxygens. You get carbon dioxide gas and water. All right, and then we balance the equations of 2, and then this one will be 3 and 7/2. Right? So let's say this is the amount that the equation is given, and they also give you some informations here. So let's say they give enthalpy change of formations of C2H6, enthalpy change of formations for carbon dioxide gas, enthalpy change of formations for water. Right? They give you all three. In terms of the value, so you have to come up with your own equations. So let's say the equations for formations of C2H6 will be carbon plus hydrogen, you get C2H6, right? And then for carbon dioxide, it's carbon plus oxygen, you get CO2. Sorry, I forgot to balance this, 3, 2. And then for water is H2 plus half O2, you get H2O. Right, this is the information given, and of course they give you the value as well. For formations of C2H6, for example, it's 1100 negative kilojoules per mole. Okay, for combustion is for formations of carbon dioxide, let's say it's negative 392 kilojoules per mole, and then for water, formations of water is negative 286 kilojoules per mole. Okay, so that's the information given for the questions, and what we're going to do now, you see, from the information given here, it's actually all formations. Okay, so by right, you can use the formula of product minus reactant. Okay, now why is it product minus reactant in this case? So I'm going to show you how we do a Hess law in the proper way. Okay, in the not the proper way, not to say the proper way is the usual the official way of calculating using Hess law. All right, so these are the information given, and then let's say we have this. Rewrite it again, C2H6 plus O2, and then you get carbon dioxide gas and water, and then by right 2 carbon dioxide and 3, and then 7/2. Now in terms of Hess law, still remember the triangle, the energy from here, the enthalpy change of this is the same as the triangle, right? They go through a different pathway. So in this case, they give you the formations of CO2, formations of C2H6, formations of water. Right? Let's put that in. So we have all these formations of carbon dioxide, formations of water. So formations of carbon dioxide gas. What are the things that need to be formed to form carbon dioxide? Is carbon and oxygen, right? And then formations of water, we need hydrogen gas and oxygen gas. We have oxygen already, we just add hydrogen here. And how to form C2H6? We have carbon and hydrogens. All right, now that's it. Now you don't have to balance it, you just need to put in the value. So from the previous whiteboard just now, the information given, how to form, what is the energy needed to form C2H6? C2H6 is negative 1100, and then to form carbon dioxide gas supposed to be negative 392, because you see I have 2 here, so times 2, and to form water is negative 286. See that I have 3, so I times 3. All right, and what to do according to Hess law, how to get the enthalpy change of this? The energy of this is the same as from here to here and from here to here, right? This circle, like a vector. All right, so what we're going to do, because this is opposite direction, you see that? So is positive 1100. All right, going above, so you're following the direction, same as the blue arrow. The red arrow is same as the blue arrow, means this follow the same arrow, plus with negative 392, 392 times 2, plus with negative 286 times 3. And then you get your final answer. All right? Now, if you use product minus reactant, what does that mean? I use a total energy here, which is 2 times negative 2,392 plus with, plus with 3 times negative 286, right? And then minus the reactant, which is negative 11. So minus negative 1100. So you're actually getting minus minus, you get a plus. So automatically product minus reactant is giving you the same calculations. So that's why they work it out. From instead of Hess law, drawing these complicated diagrams, you actually can use this product minus reactant to calculate it. So same thing goes to combustions, because combustion is different. Combustion means it's no longer this one. Okay, I'll show you another one. So I show you another one. If it is combustions, then it will be like that. For example, the same equation, guys. Let's say it's still ethane, right? It's still ethane, but I'm giving you this carbon plus hydrogen. You get C2H6. So I want the enthalpy change of this. Okay, and then the information given is combustions of carbon, combustions of hydrogen, and then combustions of C2H6. All right, so the energy negative 392, I'm giving the same, and then this is negative 286, and this is negative 1100. For example, this is the information given. And you see that all givens are actually combustions. Then you can use reactant minus product. All right, I'm showing you why reactant minus product. So according to Hess law, it's supposed to be like that. Now, combustions of carbon, okay, means carbon burned with oxygen, you get carbon dioxide gas. Combustions of hydrogen means burned with oxygen, you get water. Okay, and then combustions of C2H6, you burn it, you get both carbon dioxide and water. So this is the diagram, the triangle. So what is the energy here? We put in the energy for each of these arrow, and then we apply Hess law. So from carbon to carbon dioxide is negative 292, and then from hydrogen to water is negative 286, and then from combustions of C2H6 is negative 1100. For example, that's the case. And then when we apply Hess law means, what is the energy here? The energy should be from here add up to here, right? So it's negative 392. Okay, negative 392. And then, sorry, I forgot to balance. So it's supposed to be 2. That's why I times 2. Okay, and then here is actually plus with negative 286 times 3, because it's 3 here. And then what we're going to do, against the arrow again, you see that? Against the arrow, so it's negative minus, is plus 1100, because against the arrow means the arrow will change to positive. So this is the calculations. But if you apply the formula of reactants minus product, okay, reactants minus product. So reactant minus product means, let's see whether the calculation is the same. Reactant is 2 carbon, so 2 times negative 392 plus with 3 hydrogen, so 3 times negative 286, right? Minus product, so I minus negative 1100, means minus minus you get plus. So this calculation and this calculation basically the same. So they work out, instead of drawing these complicated diagrams, they work it out. If it is combustion given, then you use reactant minus product. Okay, so I hope this is help, but you can just yeah. All right, so hopefully this help.